So our final speaker in this session is Joan Rose. Joan's professor in the Department of Fisheries and Wildlife at Michigan State University, our great friends up north from here. She's also the co-director of the Center for Advancing Microbial Risk and co-director of the Center for Water Sciences at Michigan State University. Joan.
Thank you. Well, thank you for the invitation here. I think that you've been hearing about the issues that are stressing our ideas of sustainability. Today we've been talking about, or this afternoon, and I guess it's a good thing I followed David, I'm going to be talking about water quality specifically. And certainly population growth is one of the stressors on water quantity and quality, but it's certainly, there's regional growth, and there's travel and tourism and urbanization are other areas. Climate change is also interconnected to this idea, and we heard earlier about whether we can use recycling to address that. But water quality is one of those areas that's more difficult to address, I think, from a sustainability standpoint. What does it mean? Quantity, we know how to measure it. We understand that it's flow, that it's a volume. We have a lot more tools and techniques, from satellite imagery to real-time monitoring stations on quantity. But with quality, quality is changing. Our idea of what is quality is changing, and it's quite complex. So it can be the chemical side, it can be the biological side, and it can be the effect side. Certainly these extreme events are associated with these threats to water quality. Even the earthquakes that we've seen, earthquakes recently in China, in Christchurch, in Japan, in Haiti, are all affecting infrastructure and water quality. Our land use decisions and the coastal pressures, emerging contaminants that we found, and of course the quantity-quality issues intricately linked. Now, the Great Lakes are, as most of you know that are here, let's see. Press really hard. There we go. The Great Lakes here in this region is part of the coastal system. So we are part of NOAA, and we're part of a number of federal agencies that govern mostly marine systems. But of course, the Great Lakes represent fresh water. The Great Lakes probably represent an international basin that has one of the best compacts which focus on water quality. The Water Quality Agreement began early in the 1900s. It governs navigation, water use quality. It governs ecosystem protection, recreation, water supply, monitoring and assessment. And it has mechanisms for implementation by the government agencies on either side of the global border. Here on the U.S. side, we have 10,000 miles of coastlines in 8 different states. So these states have to come together around this compact. We represent 10% of the population, with very large cities, including Chicago, Detroit, Minneapolis, and Milwaukee. And there is it's over 4 billion when you start talking about the tourism, agriculture, and sporting fisheries industry. And I think, Don, you've recently worked with a group that's put out, an economic estimate of the value of the water, both the quantity and quality, to the Great Lakes region, and to Canada, for that matter. Michigan itself has about 10 million population. Our growing industries that have been seen as vital, but perhaps small, but are growing, are agriculture and tourism. We also have recently received funding from the federal government, which will look and invest over the next 5 years in restoration of the Great Lakes. That's the major goal. This is, Michigan, I can tell you, is taking the leadership role in both submitting proposals and in winning the grants for implementation of the research. We do have many water quality problems despite our, I guess, David has alluded to our change over the last 100 years with the Clean Water Act. And we used to have typhoid in Chicago and Detroit and dysentery, so we've taken care of some of those things. We've started to decrease the toxics. We've got a good toxic inventory, toxics both in our water and our fish. And so we have made great progress. But our shoreline is still relatively stressed. We have emerging contaminants. It's quite clear that throughout the United States, and the Great Lakes is no exception, that the pharmaceuticals and the new drugs that we use are found throughout our waters in the Great Lakes region. We also have identified spots which are areas of concern, called areas of concern, both Canadian and those that fall on the border. You can see this is Michigan here. We've got the Mitt and the Upper Peninsula. We're the only state that's completely in the basin, so what we do on the land affects the water. And so we have quite a few areas of concern. These areas of concern have sediment issues, water quality issues. About 10% were in violation of being a drinking water supply. In some cases, it was PAHs, PCBs, some old DDT in our sediments that still need to be cleaned up. About 30% are in violation of recreational guidelines in the United States. So they're not acceptable for swimming, and that's mostly based on the E. coli and the pathogens that David spoke about. We remain, although we've decreased our risk of waterborne disease in the United States, we continue to have what I call the plane crashes of the water industry. These outbreaks are the tip of the iceberg of the water contamination problem. And these outbreaks affect the whole community, so the whole water system must be shut down. What we've seen, although there was some success in decreasing that with implementation of rules under the Safe Drinking Water Act, recently we've seen increases, especially in our smaller communities, these outbreaks in our smaller communities. You can't see this. That's the recreational outbreaks from ambient waters, that is lakes and rivers. And we continue to have outbreaks associated with using our recreational beaches. Let's see how this shows up. Okay, that shows up all right. So this is a map of the United States and the drinking water outbreaks. This is just drinking water. Every place where there's a circle has been an outbreak. And every place where there's a small little gray center, the outbreak is related to extreme precipitation. So we've been able to statistically relate anytime there's an outbreak in the community where the whole community's water supply is contaminated, that the rainfall is a contributing factor. It is pushing the contaminants into the drinking water system. The Washington Post put this in the newspaper, and they overlaid the outbreak data with combined sewer overflows, all these little black dots, and David mentioned one of the combined sewer overflows. These are one of the sources, only one of the sources of these potential outbreaks. And of course, they listed the many, many pathogens associated with both drinking water, but also the recreational outbreaks, although those aren't plotted on this map. The types of pathogens we're concerned with are viruses, bacteria, and parasites, the animal kingdom, bacteria like E. coli, and the viruses. We used to think that these were associated with just diarrhea, but we now know that these are causing both chronic and acute effects, and respiratory effects, as well as diabetes, myocarditis, reactive arthritis, ulcers, hemolytic uremic syndrome, And so this is what's under that iceberg. And we have a number of outbreaks where we've had these problems. Now, human waste, sewage treatment plants, septic tanks, CSOs are not the only source of these pathogens. The way we handle animal waste, which is part of that non-point source, contributes to the pollution of the water and impacts our public health. And we are particularly concerned with some of the bacteria and the parasites and the role of antibiotic resistance, the interplay between use of antibiotics in humans, use in animals, and how that affects resistance in the human population. One of the largest waterborne outbreaks ever documented, even from the 1920s, occurred in the Great Lakes in Milwaukee. 400,000 people, 50% of the population was sick. 100 people died from tap water. The cattle were blamed as well as sewage. The drinking water at that time met all regulations, and this outbreak, of course, pushed the change in our Safe Drinking Water Act and in some of our Clean Water Act. And it also made people realize we needed hydrodynamic modeling. We need to understand where the contaminants were coming from, how they were getting to our water treatment, and could we get rid of them. This happened in 1993 and is still one of the very largest outbreaks we've ever had. More recently, we had a smaller outbreak just north of here in Canada. This was a groundwater system, but we have very similar farms in Michigan and throughout the Great Lakes as in Ontario. This was caused by two organisms, E. coli L157 and Campylobacter. Small place, but 2,000 people, a big percentage of the population sick. 7 people died, mostly children, and 30 people had HUS. This means that the children will have to get kidney transplants later in life. And this is a big problem for our small communities throughout the United States, and I would imagine that we may have similar problems in China. We've had another recent waterborne outbreak in the Great Lakes in Lake Erie. This was an island, used groundwater. The source was septic tanks, septage, and probably packaged wastewater treatment plants that impacted the water supply. The rain event and wind events contaminated all of the groundwater in the area. We've also had our share of recreational outbreaks, mostly been documented with a virus now called norovirus. You may have heard about it because it is famous for its outbreaks on cruise ships. So if you take a cruise ship, you have to be aware and wary of the norovirus. We've had one recently here in the Great Lakes region. We have some of these new types of recreational venues in which we're recycling water. And it means that we have to pay more attention to high flow water treatment. I think the technology that we use for stormwater, that we use for reclaimed and recycled water, can be used for these venues and improve the water quality. The virus hangs out. So once the virus is there, it can hang out in the sand and in other places and recontaminate and cause more disease as people use the park. This is our CSOs that we're trying to fix. It's a very expensive system where we combine our sewers and our stormwaters. These are our sewage treatment plants, many of them small. So we have many, many sewage treatment plants in Michigan that discharge to our rivers. And we have the most septic tanks, on-site wastewater systems of any state along the Great Lakes shoreline. And our shoreline is sandy, and this is also a big source of contamination. We are having problems along our shore from our surface waters, and you can see it here. If we have sewage spills, we often close the beaches. This is from, I think, the Washington Post, a cartoon where they closed the beach And the lifeguard is saying, I adore the beauty and the tranquility of these raw sewage days where no one is at the beach. We have many beach closures because of these areas. This is our map of our monitoring. So we have extensive monitoring around our shoreline. David, I don't think it's as good interior, especially where some of these TMDLs are. We don't have as good a monitoring, but some of these inland areas are as a result of the TMDLs. The yellow are where we have daily problems. They show up every once in a while. The red is where we have chronic pollution problems along our shoreline. And you can see where our population, where our high populations lie. Now, while we may have a B grade of Clean Water Act, our infrastructure is degrading, and it's been estimated that we need billions of dollars to fix our drinking water and wastewater systems, and including our stormwaters. In Michigan alone, $400 billion or 400 billion may be needed in the U.S., and in Michigan alone, they've already spent $2 billion, and I think another $4 billion is needed, particularly on the wastewater side. Now, I think that China has many similar challenges as Michigan has. This is a report. It does not say specifically in this report what is causing the water quality degradation. I imagine it's a very long list of both chemicals and microbial pollutants. But they're starting to assess with the China EPA the different rivers and their level of pollution. Toxic algal blooms, as we know, are an issue. They're an issue here in the Great Lakes, and they are an issue in China. This is a direct, well, we don't know what the exact relationship is with nutrients. The nutrients are part of the problem, and trying to build those models and correct the problem, I think, is one of the future scientific collaborations that are going on between Michigan scientists and scientists in China. And one of the other areas is the relationship between the algal blooms and blooms of E. coli, blooms of other pathogens. We've had bird deaths in the Great Lakes due to a pathogen called Clostridium. It kills the birds, and they believe that it's partly related to these blooms. We're also seeing E. coli bloom with these algae, so some of the fecal indicators we use will bloom with these algae. And we're having both fishing and recreational issues. In the United States, the only guideline is for drinking water, but the World Health Organization has recognized that algal blooms must be focused on recreational waters as well. And I believe in China, they are focusing on the WHO guidelines for control. Now, I did find a report. This is a report that was published in December 2010 of some of the national infectious diseases. You can see that 68%, and this is for the whole nation, are non-infectious diseases. So these would not be associated with water pollution. The other, we see that we do have 2% of the cases associated with bacillus and amoebic dysentery. These are some of the parasites. Hand, foot, and mouth disease continues to be one of the issues. This is a virus. Many of you may know it can be transmitted via the environment as well as person to person, and it is shed in the environment, and the role of water has not been sorted out completely. Certainly hepatitis, infectious diarrhea has been spread by water and documented in China. So this is 1 month snapshot of some of the diseases, and I did not have all the locales of where these might be occurring. Certainly, the challenges are going to be focused on the water infrastructure in China. This was a report given in 2008 on the drinking water supply. Right now, 97% of the urban population is covered, and they're improving the coverage of the rural environment, and that was where the challenge was in covering, gaining access to tap water in the rural area. The wastewater side has always been a bigger effort. I believe they're looking at different kinds of designs of wastewater systems, but in certain areas, certainly wastewater reclamation systems, perhaps looking at what Singapore has done, is being considered. I'd just like to end to say that with water quality, one of the things that we have at our hands, and one of the things we're doing here in Michigan, is really looking at the new technology that can give us a handle on water quality or tell us what is healthy. This helps us monitor sources. It helps us look at pathogens and pathogen discovery. It gives us rapid testing. Most of the time, it's focused on this DNA technology. So the explosion in the human genome and the microbial human and genomic studies that have been going on have started to impact what we do in water. So we can then use and look for DNA with quantitative assessment that's very rapid. It gives us better specificity and better resolution. We use techniques called polymerase chain reaction, which has now been quantified, and we now have machines and instruments that are much more robust, and which we can get quantitative information about the organisms that are there. We've been able to go into rivers in Michigan where we do have wastewater and CSOs, where we're trying to make improvements, and instead of looking for E. coli, the indicator, which is not very satisfactory in telling us where the sources are, what do we do about it, what is the health risk, we can begin to sort out the types of pathogens that are there. Respiratory pathogens as well as enteric pathogens. We've also been able to look for over 40 to 50 different types of organisms using chip technology, and distinguish then what percentage of that loading may be coming from the non-point source. The pathogen discovery, what we found is that we have a seasonality. We'll see if I don't know that the movie didn't, get added to the computer. But we've been able to follow the human infection and what's being excreted from the population into sewage and into the water system using microarray technology. And we certainly are seeing a seasonality in terms of the disease. And this links our water quality back to our health. So I think that we're going to be focusing on a water microbiome project for pathogen discovery, characterization, and control. We're working with, within the Great Lakes with the Center of Excellence for Great Lakes and Human Health. This is the Great Lakes Environmental Research Laboratory that's part of NOAA and is focusing on multiple issues. And we hope to revisit 100 years later the 1914 study that was done along the Great Lakes. This study was done because of the pollution and because of the outbreaks, the disease outbreaks. It was using the best technology of the time, which was just total coliforms. I find it amazing. It was the first use of GIS, beautiful handmade maps of the pollution. It's a fantastic report. So first use of GIS. 19,000 laboratories were set up to look at the basin. 90,000 samples were collected for analysis. We would like to redo the Great Lakes experiment 100 years later with our new tools. We believe that this can serve as a model for many other great river basins, other international basins that are beginning to be restored. Where are we going to put our dollar in the future for protection of water quality? So we hope that this will be a model. It'll be collaboratory with many, many partners. It'll use best methods, mapping, and it'll be communication with coalitions of the willing to focus in on water quality. You can join the international collaboration for testing of sewage and markers, and you can find this if you Google, if you go to Michigan State University's website and Google the Center for Water Science, CWS, you will come to our website and find the IC Sewage Collaboratory. We have 45 laboratories that have joined now, and we have over 30 countries represented. I would have to say we have a gap in Asia. We do not have enough partners yet who have joined us from Asia and China, where there is much work to do together. So please, if you're interested or have a colleague who would be interested, please come look at our website and join us. I'll end here and just say that water safety is complex. If we talk about security and safety as a term for sustainability around water, I think that we need to look at technology advancement in water quality testing. We need to understand risk. Goes back to Professor, your presentation on using risk assessment appropriately. Environmental issues in terms of transport, fate, what we do on the land, and obviously our control. Thank you for inviting me here this afternoon.